From generic butterfly valves to realistic manufacturer models, today I will show everything you need to know to create professional butterfly valves in AutoCAD Plant 3D. We will download real models, prepare them for Plant 3D, create smart connections, set up properties, and make our piping systems look much more realistic. First, let's take a look at what AutoCAD Plant 3D already gives us in its standard library. Butterfly valve directly from the standard library, good if you just need a fast valve placement with no detailed dimensions and no realistic visual appearance. For a more advanced level, you can create your own butterfly valve from the custom parts palette. Select a butterfly valve template and adjust all dimensions according to your required specification sheet. It still will not have a realistic appearance, but dimensionally it will be correct for your project. If you model piping for contractors to build the unit, it is completely fine to use custom parts with the required dimensions. In that case, the most important thing is dimensional accuracy. But if you want your model to look visually impressive and more professional, realistic manufacturer valves make a huge difference. Now let's get into real butterfly valves, how they are built, where they are used, and what you should know before adding them into your Plant 3D projects. Butterfly valves are very common in water systems, cooling and chilled water units, pump houses, and large diameter pipelines. They are compact, lightweight, and much cheaper than many other valve types in bigger pipe sizes. There are three common butterfly valve types: wafer, lug, and flanged. Wafer butterfly valve is the most compact and commonly used butterfly valve type. It is installed between two pipe flanges and held in place by flange bolts passing around the valve body. Because of its short face-to-face length, wafer valves save a lot of space in piping systems. Wafer valves are especially practical in larger pipe diameters where gate or glow valves become much bigger and heavier. One important thing to know is that wafer valves do not have their own full flanges. They rely on the pipeline flanges on both sides for mounting and support. If you need to disconnect one side of the pipeline, once you remove the flange, both the valve itself can drop out because it is only clamped between the flanges. That usually means you need to isolate and empty the full pipe section before maintenance. This is one reason why lug-type valves are sometimes preferred in systems where one side may need to be disconnected separately. Lug butterfly valves are similar to wafer valves, but the body has threaded lugs around the valve. Each flange side is bolted separately into the valve body. This design allows one side of the pipeline to be disconnected, while the other side stays connected and supported. Because of that, lug valves are more convenient for maintenance and systems where equipment may need to be removed separately. They are usually a little heavier and more expensive than wafer valves, but they provide more flexibility and safer maintenance conditions. Flanged butterfly valves have full pipe flanges integrated into the valve body on both sides. They are bolted directly to the pipeline flanges, creating a very rigid and stable connection. This type is larger, heavier, and more expensive than wafer or lug valves, but it is also more robust and reliable for heavy-duty industrial systems, higher pressures, and larger pipe diameters. Because the valve is independently supported by its own flanges, pipeline sections can be disconnected more safely during maintenance without the valve dropping out of the line. Here I inserted a ball valve, just to compare its size with the butterfly valve. Pay attention that the ball valve is only DN100, while the butterfly valve is already DN350. This clearly shows how compact butterfly valves are in larger pipe sizes. A butterfly valve has a relatively simple construction, but each part has an important function. The main part is the valve body. This is the outer housing installed between the pipe flanges. Inside the body there is the disc. This is the rotating part that opens or blocks the flow. When the disc turns parallel to the flow, the valve is open. When it turns perpendicular, the flow is blocked. The disc is connected to the stem, sometimes also called the shaft. The stem transfers movement from the handle or actuator to the disc. On the top side there is the bonnet or neck area where the stem passes through the valve body and connects to the actuator or lever handle. Around the disc there is also a seat or sealing ring. This part creates sealing when the valve closes and prevents leakage. Pay attention while modeling to leave enough free space around the valve disc. When the butterfly valve opens, the edge of the disc goes slightly beyond the flange area, so if another component is placed too close, it can interfere or even touch the disc. While modeling, make sure to add accurate descriptions to your valves. Once the descriptions are properly filled in, you will get clean and professional isometric and orthographic drawings with correct bill of materials information. If you want these butterfly valve models, I downloaded them for free from Free-Findig. You just need to create a free account, and you can access thousands of manufacturer components. If you want to see more real engineering practice, smart plant 3D workflows, and realistic industrial modeling, subscribe.